In today's class, we are going to see about Bowley lattice diagram. This is a convenient diagram which actually devised by Bowley, which shows at a glance the position and direction of motion of every incident and reflected and transmitted wave on the system at every instant of time. So this is the beauty of this lattice diagram. The diagram overcomes the difficulty of otherwise keeping track of the multiplicity of successive reflections at the various junctions. So these are the things to be considered from a diagrams. So the diagram overcomes the difficulty of otherwise keeping track of the multiplicity of successive reflections at the various junctions. So here we are going to consider the transmission line having a resistance R and inductance I and capacitance C and the conductance G, which all are per unit length. So by this only we are going to move further and understand the purpose of lattice diagram, which has been devised by Bowley. So you can see here normally this kind of diagram, the straightaway conveys the actually how it is going to straightaway related with the parameters which is being depicted in the diagrams. So in a voltage source, particularly the surge of a magnitude unity, which actually reaches a junction between two sections with the surge impedance, normally we'll be naming it as Z1 and Z2. Then part of a transmitted and part will be a reflected back, which actually happens in the high voltage surges. In transversing the second line, if the attenuation factor we are keeping it as K, then on reaching the transmission at the end of the second line, then its amplitude would be reduced. So this normally happens not only for the voltage surge, almost all abnormalities will face this kind of issues. This lattice diagram may now be constructed as follows. Set the ends of lines at intervals equal to the time of transit of each lines. If a suitable time scale is chosen, then the diagonals of a diagram shows the passage of the waves. So this is the way in which the lattice diagrams can be constructed by putting few more parameters in this lattice. So particularly in the Bowley lattice diagram, the following point will actually exist. The first point you can see here, all the waves travel downhill because time always increases. The position of any wave at any time can be deduced directly from the diagram. The total potential at any point at any time, which is superposition of all the waves which have arrived at that particular point until that instant of time, which normally displays in the position from the intervals, which is really equal to the difference in time intervals when it's been arrived. So this point is a very important point which uh, we have to emphasize while dealing with the Bowley lattice diagrams. The history of the wave is easily traced normally in this diagram. It is possible to find where it come from and just what other waves went into the compositions. So easily we can find where it actually comes and how that composition has been framed. Attenuation is included so that the wave arriving at a far end of a line corresponds to the value of entering multiplied by the attenuation factor of the line. So by this we can able to understand or the property which actually that lattice diagram particularly devised by the Bowley is being applied for the study of high voltages. So the first point is all waves most probably travel downhill because the time always increases. So finally you can see here attenuation is included so that the wave arriving at the far end of the line corresponds to the wave that is entering multiplied by the attenuation factors, which will give the clear picture about that voltage surges when we have two sections such as surge impedance Z1 and Z2. Today we are going to see about over voltages in electrical power systems. So under this we have switching surges, causes of over voltage, lightning phenomenon, charge formation of lightning, rate of charging of thundercloud, mechanism of lightning strokes, characteristics of lightning strokes. So now we are going to see switching surges. Normally, the switching surges will occur within the power system. So in switching, the over voltage thus generated actually lasts for longer durations. So it is considered to be a much severe and more dangerous, which has to be prevented at the earliest, if not at the earliest, at least at the time of occurrence of switching surges. This switching surges normally depends upon the normal rated voltage. So whenever rated voltage increase, the switching surges voltage will also get increased. So now we are going to see the origin of switching surges. Normally in a power system, we frequently will try to make and break electric circuits with switch gears, which normally results in abnormal over voltages, which will have a large inductance and capacitance, which has to be optimized at the initial stage itself. This over voltage may go as high as 6 times the normal power frequency voltages. So, if it is 6 times means nearly the entire system gets damaged, so it has to be prevented at the earliest. So, these are the characteristics of switching surges. The first one is de-energizing of transmission lines, cables, shunt capacitor, and capacitor bank. Disconnections of unloaded transformers and reactors, particularly light limiting reactors. So energization or reclosing of lines and reactive loads, which normally leads to severe switching surges in the system. Sudden switching off of loads, which considered to be too dangerous at the time of operation of the systems. Short circuit and fault clearance. So whenever fault has been cleared, immediately after the clearance of fault, there's a possibility of switching surges. So we have to be more cautious at the time of clearing the faults. A resonance phenomenon like further resonance, arcing rounds, etc. These are the important key characteristics of switching surges, which we have to keep in mind at the time of analyzing switching surges. Next, control of over voltage due to switchings. So the switching over voltage can be controlled with some of the traditional techniques. The first one is energization of transmission lines in one or more steps by just inserting resistance and withdrawing them afterwards. So just by adding a resistance initially and then by removing it, we can able to overcome the switching voltages. Phase control closing of circuit breakers, drainage of trapped charges before reclosing, particularly it will be done at the transformer end. Use of shunt reactors, which traditional techniques most probably will be using to reduce the switching surges, limiting switching surges